Assalamualaikum. My name is Fatiha Nur Subhana, and in this video, I will be presenting the frequency analysis and reliability test using IBM SPSS statistics software. Before we start, I would like to explain what is descriptive analysis. Descriptive analysis is used to describe and summarize the data collected from respondents. It helps researchers understand the characteristics of the respondents, identify patterns in responses, and interpret the findings more clearly. This analysis is also important for checking the consistency and accuracy of questionnaire items, ensuring that the data reflects the variables being measured and helping to answer the research questions effectively. So, descriptive analysis can be divided into two types. So, the first one is categorical variables, which is frequency analysis. Frequency analysis is used for categorical data. It shows how many respondents selected each response category and presents the data in terms of frequencies and percentages. And second, continuous variables, which is descriptive statistics. Descriptive statistics are used for continuous data, such as items measured using a 5-point Likert scale. The analysis includes measures such as mean, median, and standard deviation to describe the central tendency and distribution of the data. For this task, we were provided with three main components: a conceptual framework, a set of questionnaires, and a data set. Using these materials, we will perform statistical analysis to better understand the data collected from the respondents. First, let us begin with the frequency analysis. Frequency analysis is a statistical procedure used to summarize and describe both categorical and numerical data by displaying the frequency and percentage of each response or value in a dataset. Its purpose is to provide a clear overview of data distribution, identify patterns and trends, and present respondents' characteristics and responses in an organized and meaningful manner. So without further ado, let's proceed with the frequency analysis. To begin, we click on the Analyze tab, then select Descriptive Statistics, followed by Frequencies. So here, we can see the variable section. For this demonstration, we will select the variable purpose and move it into the analysis box. Next, click on the Statistic button. Under the Central Tendency section, select Mean, Median, Mode, and Sum. Then, under the Dispersion section, select Standard Deviation. Once all the required options have been selected, click Continue and then click OK. The output generated consists of two tables: the statistic table and the frequency distribution table for the purpose variable. Based on the statistic table, a total of 235 respondents answered the questionnaire, with no missing data recorded. So the mean value is 1.5787. This indicates that on average, respondents selected holiday category for the purpose variable. Next, the median value is 1.0000. This means that half of the respondents scored below this value, while the other half scored above it. The mode is 1.00, indicating the most frequently selected response among the respondents. The standard deviation is 1.03629. This value shows the level of variation or dispersion in the respondent's answer. A lower standard deviation indicates that the responses are more consistent, whereas a higher standard deviation suggests greater variability. Lastly, the sum is 3.371.00, representing the total accumulated score for this variable across all respondents. Referring to the frequency distribution table, it can be observed that the highest percentage of responses was recorded for holiday, which is 74.9%, indicating a strong preference among respondents for this aspect of purpose. This suggests that respondents generally perceive this characteristic positively and consider it an important factor. However, the lowest percentage of responses was recorded for business, which is 0.9. This may indicate that fewer respondents agreed with this statement or considered this aspect less important compared to the others. Overall, the findings suggest that holiday is an important factor influencing respondents' perceptions and preferences. Moving on to the next section, we will conduct the reliability test using the data set provided. This analysis is carried out to determine the consistency and reliability of the questionnaire items used in this study. So moving on, in this part, reliability analysis is used to measure the internal consistency of a set of questionnaire items and determine whether the items consistently measure the same construct or variable. So in other words, it helps researchers assess the reliability and stability of the measurement instrument. So for example, based on the conceptual framework, I will select the variable taste and quality value. Referring to the questionnaire, these are the three items that are related to this variable. So now, we will demonstrate how to conduct a reliability analysis using SPSS. First, click on the Analyze tab, and then select Scale, followed by Reliability Analysis. Next, select the three questionnaire items related to the taste and quality value variable and move them into the items box. Then, click on the Statistics button. Under the Descriptives for section, tick Item, Scale and Scale if item deleted under the Inter-Item section, and then tick Correlations. Lastly, under the Summary section, tick Correlations. Next, enter food as the scale label. Once all the required options have been selected, click Continue and then click OK. So the output displayed shows the results of the reliability analysis using the Chromebacks Alpha. As we can see at the top of the output, the scale is labeled food as specified earlier. First, let us examine the case processing summary table. The result shows that there were 253 valid respondents, representing 100% of the total sample. No cases were excluded or removed due to missing data. This indicates that the data set is complete and suitable for further analysis. Next, we will evaluate the reliability statistic table. The reliability analysis was conducted using Chromebacks Alpha. The results show a Chromebacks Alpha value of 0.912 for the three items, indicating excellent internal consistency among the items. In addition, the standardized Chromebacks Alpha value is 0.913, which is very close to the original Chromebacks Alpha value. This suggests that the items have relatively similar variances and are highly consistent in measuring the same construct. So, according to the commonly accepted guideline, a Chromebacks Alpha value above 0.90 indicates excellent reliability. Therefore, the instrument can be considered highly reliable and demonstrates strong internal consistency for further statistical analysis. Overall, the findings indicate that all three items are reliable measures for the taste quality value variable, and the responses obtained from the 253 respondents can be confidently used for further analysis. Next, let us examine the item statistics table. In this table, we focus on the mean and standard deviation columns. The mean values are 3.8170, 3.7830, and 4.0894 respectively. These values indicate that respondents generally agree with the statements related to taste and quality value, as all mean score are close to 4 on the Likert scale. The standard deviation values are 0.98087, 0.95168, and 1.01931. These values suggest a moderate level of variation in respondents' responses. We can also observe that the number of respondents shown under N column is 235 for all three items, indicating that the same respondents were included in the reliability analysis. Finally, let us examine the inter-item correlation matrix. Here, we focus on the correlation values between the three items. The key values are 0.827, 0.760, and 0.743. These values can be found in the cells where the items intersect with one another. The highest correlation is 0.827, while the lowest correlation is 0.743. These values indicate strong positive relationships among the items, suggesting that they consistently measure the same underlying construct. At the same time, none of the correlation values exceed 0.90. This means that there is no evidence of item redundancy. In other words, although the items are strongly related, they are not repetitive and each item contributes meaningful information to the measurement of taste and quality value. Therefore, based on the Cronbach's alpha value of 0.912 and the inter-item correlations ranging from 0.743 to 0.827, we can conclude that the taste and quality value scale demonstrates excellent reliability and strong internal consistency. All three items should be retained for further statistical analysis. Next, we examine the summary item statistic table. The mean inter-item correlation is 0.777, indicating a strong relationship among the three taste and quality value items. The correlations range from 0.743 to 0.827, showing that the items consistently measure the same construct. Since none of the values exceed 0.90, there is no indication of redundancy among the items. Next, we focus on the corrected item total correlation column. The values range from 0.786 to 0.849. Since all values are substantially higher than the recommended threshold of 0.30, each item demonstrates a strong relationship with the overall scale and contributes positively to measuring the taste and quality value construct. We can also examine the Cronbach's alpha if item deleted column. If any of the three items were removed, the Cronbach's alpha value would decrease from 0.912 to values ranging between 0.851 and 0.905. This indicates that each item contributes positively to the overall reliability of the scale. Therefore, none of the items should be removed. Lastly, the scale statistic table shows the overall mean score of 11.6894 for the three item taste and quality value scale with a standard deviation of 2.72243. This provides a summary of respondents' overall responses to the scale. So that's all from me. I will pass the presentation to my next member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iffatul Husna binti Muhammad Rafi. So now I will be presenting about t-test and ANOVA. So before we conducting the statistical analysis, the total score for each factor is computed using the compute variable function in SPSS. So before we conducting the statistical analysis, the total score for each factor is computed using the compute variable function in SPSS. The computation is performed by selecting transform, then compute variable, label the total of variable, which is the first one is taste and quality, bracket taste and quality 1 plus taste quality 2 plus taste quality 3, then divide into 3, click OK. So move in to the next IV, transform compute variable, Reset. Labeling the other variable, the health value. Okay, click bracket, health value 1, health value 2, health value 3, divide 3. Click OK. Okay, so we are going to compute all the variables to get the totals. So, t-test is a statistical test used to determine whether there is a significant difference between the mean scores of two independent groups. The significance value, which is p-value, is used to make the decision. If the p-value is less than 0.05, there is a significant difference exists between the groups. But if the p-value is greater than 0.05, there is no significant difference exists. So next we are moving to the t-test. T-test is used to detect and observe significant difference in mean of each other. The step is in menu. First we have to click analyze, then click compare mean and proportions. Click independent samples t-test. In the text variable box, we enter variable that we desire, and in this case, I would choose total attractiveness factor that we have computed. For grouping variable, we choose a categorical variable. If there is a question mark at the end of the sentence, you have to click define group and click continue and OK button. So here I want to find the significant difference between attractiveness factor for men and women. Firstly, we look at group statistic box, and there are 63 male respondent and 172 respondent are women, and total for these two equal to 235 people. So there is no missing data. Moving on to independent sample test box, the significance is 0.986, which is larger than 0.05. So we need to read other information using the first line and equal variance assumed. To find out whether there is a significant difference between these two groups, we can refer to labeled significant two-tailed, which is 0.562 as stated here. Since the value is above 0.05, there is no significant difference between the two groups. For ANOVA, it is a statistical test that used to determine whether there are significant difference among the mean scores of three or more independent groups. The test compares the variation between groups and within the groups. If the p-value is less than 0.05, at least one group differs significantly from the others. If the p-value is greater than 0.05, there is no significant difference exists among the groups. For ANOVA test, we want to observe is there a difference in total emotional in different age group, which in the questionnaire it comprised of 18 to 24 years old, 25 to 34, 35 to 49, 50 to 64, and the last one is 65 years old and above. So how to run ANOVA test if go to menu tab? So first thing first, we have to search for analyze, then click compare means and proportion again. But this time we choose one-way ANOVA. So choose the factor we want, and I am gonna choose age, while for dependent list, though I run many variable at once, let's focus on total emotional factor. So click option button and click descriptive. Then homogeneity of variant test, Brown Forsyth test, and Weld test. In missing values section, click on exclude cases analysis by analysis and click continue. While in post hoc button, click to key and continue, then click OK. So in descriptive box, all data 235 respondent data is included without missing any. So moving on to ANOVA box, the significance value of total emotional is 0.203, which is greater than 0.05. This means no significant difference between emotional value in each group. So that's all from me. So I'm going to pass this presentation to my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name is Husna Nadhirah binti Hafizi. So I'm gonna show you how to do correlation and regression part. For correlation describes strength and direction of linear relationship between two variables. So how to run correlation? First, on the menu button, we choose analyze. So for correlate and correlate, and we choose bivariate. We select two variables, which is IV and DV. So the DV is destination image. The IV that I would like to choose is emotional value. Correlation coefficient, make sure we take on Pearson. At test of significance, make sure we click on two tail and make sure we click on the flag significant correlation. For in the option button, in missing value, we need to click on exclude cases pairwise, then continue and OK. So based on this number 235, which is the total of respondent that we have, so like based on the Pearson correlation, we'll take a look at this number. Since it is 0.672, that means the direction of this relationship is positive. Pearson correlation coefficient is 0.672, indicate positive correlation between destination image and emotional value. Yes, fine. Then for the determination of relationship, we need to consider the size of value of correlation coefficient. Just now the number is 0.672. Then depending on this box, referring on this box, since it is 0.672, is 672. The scale strength of this relationship is large. Then we need to calculate the coefficient of determination, where we search for R square, which basically we just click on this number 0.672. We times it with the same number, which we derive 0.45. Then we need to times it by 100 because we wanted to make it into percentage, and we get 45%. So destination image help to explain nearly 45% of variance in the respondent score of emotional value scale. Accessing, then we need to access significant level, which is smaller than 0.001, which is significant. Moving on to regression. Regression allows student and researcher to test a lot of tests and compare variables, a lot of variables at once. It's also helped to explore relationship between independent variable with dependent variable. It also helped to identify which variable has strongest impact on the dependent variable. While this test is ideal for investigation of more complex case or study. Here's how we can get our regression result. First, on the menu, we choose analyze, then regression, and choose linear. we enter dependent variable. Then for the dependent, depend on what we want. So I'm interested in emotional value as well as perceived value. Then on statistic button, we choose estimate, confidence intervals, model fit, descriptive, part and partial correlations, coordinatory diagnostic. In residual, we choose case-wise diagnostic, outliers outside tree. Just continue. Option button, which is excluded cases pairwise. Continue. In the plot button, ZP RE is IDs for X, while at ZP rate is for the X. Normal probability plot, probability plot. Then we click on continue on the save button. Distance, Mahalonus and quotes. Continue and OK. So first we take a look at correlation table comparison. So it have to be above 0.3. Above 0.3 and not exceeding 0.7. So both of this variable is fine. Both scale correlate substantially with destination image. So in the coefficient table, we take a look at the tolerance and VIF. We need to check for the multicollinearity, and the tolerance needs to be less than 0.10. It's already exceeding. The VIF is above 10. In the relationship here, we could see that multicollinearity because it's not the same in the p-plot. Based on the graph, we can see it's quite normal because most of the data is centered around the line. Then for the scatter plot need to be between 3.3 to negative 3.3, and the shape of the scatter plot need to be like a rectangle. Then most score need to be concentrated around 0 for it to be considered as a good result. So in the summary table, model summary table, we check on the R-square. Confidence how far IV explained DV. So our R-square is 0.480. We need to convert it into a percentage. So we times it by 100, equal to 48%. For the ANOVA, the significance is less than 0.001, which is strongly significant. Overall, we have answered few of the research question, which is first to recognize variance of DV over Booth's IV, while the second one we can see which one between the two independent variable is the best contributor, and take a look at the standardized coefficient beta. These two, we can see that emotional value is higher than the perceived value with a 0.516. And we take a look at the significant, which is both of it is highly significant because it is smaller than 0.05. So this framework have two significant variable, which both of them are statistically significant with destination image, while the greatest predictor for destination image is emotional value.